In this section we have a look at three examples of how we apply the compound interest formula. Let's first of all have a look at some of the variables involved. A is the total amount of money that we have in the account after the investment period is over. Alternatively, it's the amount of money that we actually owe after the borrowing period is over. P refers to the principal, the amount of money we invest or borrow. R is the rate of interest, which is expressed as a percentage, but for the sake of the formula we put it as a decimal. T is the time for the investing or borrowing, and that's expressed in years. And N is the number of interest calculations that take place per year. For example, if the interest is calculated monthly, that means that there's 12 interest calculations within the year. When starting to use the compound interest formula for the first time, we tend to use this formula expressed here. Now that refers to the number of interest calculations as being one per year or being done annually. Let's have a look at the first example. It'd be wise to pause here and then read through. In a few seconds we'll have a look at the solution. Okay, we've highlighted some of the key parts of the formula. P is the principal in red, that's 8,500. The rate as a percentage is 6% per annum, that's in orange. It's actually calculated annually, so that means that N is equal to 1. And the 5-year period refers to the time for the investment. Because N is equal to 1, we can go to the simpler formula for compound interest, which we've shown here. So there's no N involved because N is expressed as just 1 unit. Okay, so in our formula, the principal is 8,500. The rate as a decimal is 0.06 and T is equal to 5. This gives us a final amount of $11,374.92, rounded to 2 decimal places for money. But that's the total amount of money. The question actually asks us for the interest that Sher earned. So what we need to do is have the total, subtract the 8,500, which is the original amount, and that gives us the interest, in other words, the extra money that's actually been earned over this investment period. Once again, for this problem, it would be a good idea to pause here, have a read through the question and see if you can work out the key components of our formula. Okay, so we've highlighted the time, that's 60 months. We'll need to convert that to years. We've got a total principal of 50,000 and we've got a rate of interest of 7.03%. Notice also that it's compounding annually, so N's equal to 1. So we refer to the formula without the N involved, the one shown below there in black, and we'll use that one for this question. Okay, the principal's $50,000. The rate of interest as a decimal, we need to divide our 7.03% by 100 to get 0.0703. And we need to divide the time by 12 because it's in months at the moment. So 60 divided by 12 is the number of years. When we do all of that, we end up with the amount being $70,225.95. And that does answer the question because it was asking how much is the total amount of money at the end of that investment period, so we don't need to work out the interest. This is our third example, and once again it would be wise to pause here and have a read through the question and see if you can work out the key aspects before we go through and solve it. Okay, we notice here that the principal is once again in red, $50,000. The time is in years, that's 6 years, and the interest rate is 7% per annum. But what we also notice is that the interest is calculated at the end of each month. That means that there are 12 calculations per year, and that will mean that we'll have to use the original formula with N equal to 12. If we go through and put that into the formula, we can see that we've substituted all the values into the appropriate spots. Of course, notice that N equals 12 has gone into those parts of the formula. We can work out therefore the total amount of money. So the total amount of money comes to $76,005.28. The question does ask us to work out the interest that Joe earned. So what we have to do is get the total amount of money that we found from the formula, subtract the original $50,000, and the difference between those two is the extra money, the interest that Joe's earned. And that comes to $26,005.28.